So we also want to shade above the blue line. And so whenever we do that, you can see that we did end up with a double shaded area. Okay? Be very careful about where you say that is. Here is not shaded at all. That's pretty clear. This middle portion is only shaded by the blue line, whereas it's this portion of our graph that is shaded in with both colors. Everything above, essentially it's everything that was above the red line. There we go, got my shader to work. Everything above that red line was my double shaded region, okay? Because it was above the red and above the blue. All right? Number 4 is a new type of problem we just haven't seen. Well, we've seen it. We haven't done many of them like it, okay? It just gives you the graph and says which of these 4 points is not a solution. Not a solution, okay? So we start going through them one by one. My advice, put all of them on the graph and then decide. Because some of them might be close, some of them might not be. 6, -2. This is right here. That's point A. B is -4, 0. So we're looking for whichever point is not in the double shaded region. Okay? C would be -2, 0. So C is the first one that stands out to me as I'm like, I don't know about that one. It might be right, but I'm a little uncomfortable with it. And then -2, 5, right there. That's D. This is our double shaded region. Clearly A, B, and D are all in it. And C, you sit there and wonder, but Mr. Terrell, it's in there. It's really close. But look at this line that it's on. It's on a dashed line, which means for this equation that was obviously shaded up from it, we do not include things on that line. That would be a less than sign or a greater than sign, specifically a greater than sign in that problem, which means it has to be strictly greater than this line. It cannot be on it, which is why C fails, okay? Let's say maybe there's an option E right here at the intersection. A lot of people will look at that one and be like, oh, well, obviously that one passes. It's the intersection. Or obviously it passes. It's on a straight line, a solid line. This would actually not pass either, okay? This would not pass because, again, to be a solution to a set of linear inequalities, it has to pass both of them, not just one, okay? So be careful on that one tomorrow. 5 and 6 are very straightforward. These are where we're just plugging the point in, and you have to test it for both equations. So I'm going to go ahead and split my problem up. I've got one equation, 2x minus 3y is less than -3, and 2x minus y is less than or equal to 3. Two separate problems. I test them separately, but it has to pass both. This must pass both. What that means is if it fails one of them, you can actually just stop the problem there. And I know it says show all your work, but if it fails one, that's all the work you need. That's that it's not a solution, okay? Plug in 3, 4. And what I mean by that is plug in a 3 for my x and a 4 for my y. So I have 2. And then instead of x, I'm plugging in this number 3. Minus 3. And instead of y, I'm plugging in this number 4. Sorry about that. Then I have less than -3. That's all that's changed. And now I'm going to evaluate this. This would be 6 minus 12 is less than -3. -6 is less than -3. And guys, if you're ever stumped on one, think about it on a number line, because this is in fact true. But a lot of people look and go, but Mr. Sorrell, 6 is greater than 3. Yeah, in positives. But in a negative number line, if we have 0 here, we've got -1, -2, -3, -4, -5, -6. With this being the greater than side, and the further left you go being the less than side. So if we have -3, we have to go to the less than side to get to -6, meaning -6 is less than -3, okay? Same song, second verse, 2, but instead of x, we're replacing that with our 0.3, minus y, which we're replacing with the value 4, is less than or equal to 3. Well, this would be 6 minus 4 is less than or equal to 3. 2 is less than or equal to 3, and that checks out. So your final answer is 3, 4 is a solution. Not the solution. That's a distinction that you need to make. It is a solution. There are tons of them. Think about whenever we were graphing these and we had the double shaded regions up here, okay? There's not just one solution to this problem. There's a ton. And the graph doesn't actually stop here. It goes on forever. There are infinite solutions. We were just checking now on these problems to see if this certain thing was a solution, a viable solution. Okay? Do the same thing with the second problem. Y is less than 2x plus 1. Y is greater than or equal to 4x minus 3. A little bit quicker. We're plugging in a negative 2 and a negative 6. That means we have negative 6 is less than 2 times negative 2 plus 1. Negative 6 is less than negative 4 plus 1. Negative 6 is less than negative 3, and that is a true statement. Think about it on the number line. In fact, we just had this one. That's a weird coincidence. Didn't plan on that happening, but next we plug in our numbers again. Negative 6 is greater than or equal to 4 times negative 2 minus 3. Negative 6 is greater than or equal to negative 8 minus 3. Negative 6 is greater than or equal to negative 11. And that is also a true statement. Kind of reverse of the other one, or of how it worked, okay? Still, double true statement, meaning negative 2 comma negative 6 is a solution. So I know both of those worked out right, okay? But on the quiz, if even one of them fails, then it's not a solution, okay? Even one of them fails, it's not a solution. On number 7, you simply have to write out the system of inequalities, okay? Do not bother working it out. You don't need to find a solution. That's the next problem. Follow directions. Write them out. So, Wanda's sewing small and large gloves. It takes her 1 hour to sew a pair of small gloves, 2 hours for a large pair. So I can already tell one of these is talking about time, okay? So where's my other piece of time? It's down here. Wanda has at most 16 hours. So 2 hours, 1 hour, and 16 hours. Those all go together. I'm going to let X be my small gloves and Y be my large gloves. You can also just use S and L. That's self-explanatory. You wouldn't have to list those out. Okay? So 1X, 1 hour for a small pair, plus 2Y, 2 hours for a large pair, has to be less than or equal to 16 hours. And that's tough because at most, people think, oh, most, that means greater than. At most means she cannot spend more than that amount of time, okay? More than that amount of time. I hope this isn't in one single day. Okay, hopefully this is over like a weekend or something, because that's a long time. Okay, next equation talks about money. $2 for a small pair, $4 for a large pair, and she does not want to spend any more than $40 on materials. So this is where she's trying to budget for this, okay? $2 for a small pair, $4 for a large pair, and she has to spend no more than, she doesn't want to spend any more than $40. So less than or equal to $40, okay? Less than or equal to $40. We were just setting that one up, and the reason we only set that one up is actually because these kind of are weird whenever we're double less than or double greater than, especially double greater than. That never makes sense. The double less than is a bit weird, okay? More real world applicable is a problem like number 8. Sam's trying to spruce up his basement a little bit. He wants to redo the floors with a combination of carpet and hardwood. No, not at the same spot, but part of the house carpet, part of it hardwood, okay? He wants these to cover at least 1,500 square feet of his basement in total. Carpet costs $450, hardwood costs $825. Sam has $9,000 left in his budget for the project, okay? So we're going to use the variables X and Y again. You could also, again, just use C and H for carpet and hardwood. I'm going to let X be our carpet and Y be our hardwood.